All right, let's get right into it. When you hear the name NVIDIA, what pops into your head? For most of us, it's a computer chip, right? Some piece of high-tech hardware. Well, today we're going to blow that idea wide open because the chip is just the tip of the iceberg. We're going to explore NVIDIA's AI Fortress and the deep, invisible moat that makes it so incredibly powerful. I mean, this is the question on everyone's mind in the tech world. How in the world did one single company become the undisputed king of the most important technology shift of our lifetime? Well, the answer is a lot more layered and honestly, a whole lot more brilliant than you probably think. And here it is, right up front, the single most important thing to understand. If you walk away thinking NVIDIA's dominance is just about having the fastest, most powerful chip, you're missing the entire story. The hardware is just the ticket to the game. The real magic, the true defensible moat, is the massive ecosystem they've spent almost 2 decades building around it. So for a quick level set, let's talk about the hardware at the center of all this, the GPU, or Graphics Processing Unit. Now, these things were originally designed to render incredible graphics for video games, but it turns out that their unique talent, doing tons and tons of simple math problems all at the same time, is the perfect recipe for training and running AI. NVIDIA got its start here, making the best gaming chips, but they sure didn't stop there. And to really get their strategy, you've got to understand the two halves of the AI world. First, you have training. This is the heavy lifting. It's slow, it's incredibly expensive, and it's basically like sending an AI model to college to earn a PhD. Then you have inference. That's when the trained model is out in the world, doing its job, answering your questions, generating images, you name it. It's fast and it's constant. Now, keep these two ideas, training and inference, in your head. They are absolutely critical to understanding NVIDIA's genius. Okay, so let's start peeling back the layers of this fortress. And the very first layer, the foundation of this entire empire, it's not even a piece of hardware. It's software. It is the language that virtually the entire AI world speaks. And that language is called CUDA. Now get this. Over 15 years ago, NVIDIA made a wild bet. They created this powerful software platform that lets developers talk directly to their GPUs for general-purpose computing. And they gave it away for free. Because it worked and it was free, everybody started building on it. And when I say everybody, I mean everybody. This quote just nails it. You see, a competitor can come along and maybe build a slightly faster chip. But if that chip doesn't speak CUDA, a developer has to learn a whole new language, find new tools, and leave behind a 15-year-old ecosystem of support and knowledge. It's just not going to happen. CUDA isn't just the default language. It's basically mandatory for anyone serious about AI. So, you've got this universal language that everyone uses. What do you build on top of that? Well, the second layer of the fortress is all about reliability. It's about making sure that the whole complicated mess of AI development just works. Think about an AI system like a really fragile tower. At the bottom, you have the hardware, the GPU itself. Then you have the drivers that talk to the hardware. On top of that, you have AI frameworks like PyTorch that developers use to build models. And way up at the top is the actual app that you use. The thing is, if just one of those pieces gets wobbly, the whole tower can come crashing down. Now, imagine you're a developer, and you've built this tower with parts from 4 different companies. You've got a chip from company A, drivers from company B, and so on. When it all inevitably breaks at 2 in the morning, who do you call? Whose fault is it? You spend all your time playing a blame game instead of actually getting work done. It's a total nightmare. And this is where NVIDIA's killer advantage comes in. It's what people in the industry call having one throat to choke. Now, it sounds a little intense, but it means you have one single point of accountability. The hardware, the drivers, the software, it's all from NVIDIA. It's all been tested together by millions of other developers. So if something breaks, you know exactly who to call. That peace of mind, that stability, you can't put a price on it. All right, layer 3. This one is so interesting because it's not about silicon or code, it's about people. It's about the pipeline of human talent and the incredible, expensive friction of trying to get people to change how they work. Just think about this for a second. It's genius-level, long-game strategy. Where do the next generation of AI engineers learn their trade? They learn it in university labs, which are almost all filled with NVIDIA GPUs. The courses they take teach CUDA. The internships they get use NVIDIA hardware. So by the time they graduate and get their first job, what's the only AI ecosystem they know? What language are they fluent in? Yep, NVIDIA's. And what are these engineers worth? Well, this is a pretty typical number for the total compensation of one single experienced machine learning engineer. We're talking about some of the most sought after, highly paid people on the planet. So now connect those two ideas. Let's say you're a company, and you think you can save a few bucks by buying a competitor's chip. Great. But now you have to take your team of engineers, who you're paying $500,000 a year, and tell them to learn an entirely new system from scratch. The time, the cost, the frustration, it's a massive hidden expense. That switching cost is a bigger wall than any patent.
And that brings us to the fourth and final layer of the fortress. And this is where the business model is just beautiful. It's how NVIDIA manages to win across the entire life cycle of an AI model, from birth to deployment.
Remember training and inference? This is where NVIDIA gets you coming and going. First, they sell you their huge, ultra-powerful, very expensive GPUs to train your model. Then, once it's trained, they sell you a totally different set of chips that are optimized for running inference. And, of course, they provide all this amazing free software that makes your model run way faster on their inference chips. You trained on NVIDIA, so it just makes sense to deploy on NVIDIA. It's a brilliant 1-2 punch. Now, I know what you're thinking. This is all great, but what about Google? Don't they have their own amazing AI chips? And you are absolutely right. Their custom-built TPUs are fantastic pieces of hardware, probably the most credible alternative out there. But there's a pretty big catch. Let's just break it down. With NVIDIA, you can buy their GPUs and put them in your own data center. You can rent them from any cloud provider. They're everywhere. But Google's TPUs? You can't buy them. You can only rent them, and only inside Google's cloud. Plus, the whole world is basically standardized on the PyTorch framework, which runs best on, you guessed it, NVIDIA. Google's chips prefer their own framework, JAX. So you see the difference? One is an open platform. The other is a beautiful but very walled garden. And what you end up with is fascinating. It's not one giant competitor to NVIDIA. It's the scattered chain of islands. A Google island, an Amazon island, a Microsoft island. They're all building their own custom chips, but they only work inside their own little worlds. And ironically, this just makes NVIDIA stronger, because they're the neutral ground. They're the open ocean that connects all the islands. They're the default choice that works everywhere. So let's just recap. You have the universal language, the rock-solid reliability, the human talent trap, and the win-twice business model. This fortress seems almost invincible, right? But in the world of technology, no empire lasts forever. So the big question is, what could possibly bring these walls down? Well, it's probably not going to be someone who just builds a slightly faster GPU. That's a fight on NVIDIA's home turf, and they're built to win it. No, the real threat is a fundamental change in the game. We're talking about sci-fi level stuff that's being cooked up in research labs right now. Things like neuromorphic chips that are literally structured to mimic the human brain, or optical processors that compute using beams of light. Things that change the basic rules of computing. And that really is the bottom line. To bet against NVIDIA's dominance, you can't just bet on a competitor to build a better product for today's world. You have to make a much bigger bet. You have to bet that the game itself is about to be completely upended and replaced by something new. NVIDIA's entire fortress is designed to win the current game. If the rules suddenly change, that fortress could become a museum. So for right now, today, NVIDIA isn't just winning the game of AI, they are the game. They own the stadium, they wrote the rulebook, and they're selling all the equipment. But as we've seen time and time again in tech, no game lasts forever. And so the real question isn't who's going to build a better GPU. The real question is who's out there in a garage or a lab right now inventing a whole new way to play.